Good morning, class. We are looking at Module 4, Chapter 8 review, Part 2, polar coordinates and vectors. A couple of questions we've seen already, so quickly plot the points in polar coordinates. Polar coordinates, basically we have a pole, the same as the origin, and the positive side of the x-axis. A point has coordinates x, comma, y in rectangular coordinate system, or r, comma, theta in polar, where r is the distance from the pole or the origin, and theta is the angle with the positive side of the x-axis or the polar axis. So with that being the case, minus 2 comma 0, theta is 0, so we are going this way. When r becomes negative, we go the opposite direction. That would be the answer. In this case, pi over 2 along the positive side of the y-axis, and we go 1 tick mark along that. That gives us 1 comma pi over 2. As far as finding other polar coordinates for a specific point, we will pay attention to the following. A polar coordinate is not unique. We can add 2k pi or 2n pi, where k is an integer, to theta. Or we can make the r negative, and then we add odd multiples of pi to that. So for example, right here, simply put, since we want theta to be between 0 and negative 2 pi, we subtract 2 pi from theta, which is pi over 2, to make it negative. R is negative, so you want to make the R negative, you want to make 1 negative, and then simply put, we need to add pi, odd multiples of pi. You can add pi or 3 pi or 5 pi to that. So if we add pi, we end up with negative 1 comma 3 pi over 2. If we wanted to go beyond 1 complete revolution, that means between 2 pi and 4 pi, just add a 2 pi to that, and there you have it. One comma pi over 2. Plot the points first, then find their coordinates, find the rectangular coordinates for this pair 6 comma 150. So we go 150 degrees, and then 6 tick marks, in this case those circles. Let us write the formulas. Polar has coordinates r comma theta, rectangular has coordinates x comma y, x is r cosine theta, y is r sine theta. So r cosine theta, that means 6 cosine of 150 degrees, or 5 pi over 6. As you know, in the second quadrant, sine is positive, cosine is negative. It's the same as the reference arc is 30 degrees. So cosine of 30 degrees is square root of 3 over 2, and cosine of 150 degrees, or 5 pi over 6, makes it negative. Y is r sine theta, and as I mentioned in the second quadrant, sine is positive, so sine of 30 degrees is 1/2, and the product of 6 and 1/2 is 3. Therefore, the polar coordinate 6 comma 150 corresponds to rectangular coordinates minus 3 square root of 3, comma 3. Find the polar coordinates for 2, comma negative 2. First, we have to find r. And so if we locate that, 2 to the right, 2 down, that gives us the location. The formulas x squared plus y squared is r squared, and tan theta is y over x, and you have to adjust for the quadrant. So the very first thing we calculate is x squared plus y squared. That gives us 8. 2 squared is 4. Negative 2 quantity squared is also 4. They add up to 8. Therefore, r is square root of 8, which is 2 square root of 2. As for tangent, is y over x. Minus 2 over 2 is negative 1, and theta becomes negative pi over 4. And we can keep it as negative pi over 4, or if we wanted to make it positive, all we have to do, add 2 pi, and it becomes 7 pi over 4. 7 pi over 4. You had seen this. Let's continue. We want to transform the polar equation r cosine theta equals negative 2 to an equation in rectangular coordinates. And we want to graph this. So when we look at the formulas, we notice that x is r cosine theta, y is r sine theta, and in the case of r cosine theta being negative 2, using x equals r cosine theta, that results in x being negative 2, which is simply a vertical line, VL, short for a vertical line. X equals negative 2. We want to transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graph. So first, let's write a few things here. We know x is r cosine theta, and r squared is x squared plus y squared. And in this example, r is 2 cosine theta. So the trick would be to multiply both sides by r. And when we do that, we get r squared equals 2r cosine theta. So r squared is x squared plus y squared, and 2r cosine theta is 2x. So x squared plus y squared is 2x. And that we know how to handle. All we have to do, move the 2x to the left. You put these two together. We need to add 1 because we want to complete the square. B is negative 2. If you divide it by 2, you get negative 1. And if you square that, you get positive 1. So you're going to add positive 1 to both sides. Left side becomes x minus 1 quantity squared plus y squared, and the right side is 1. The equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. Therefore, the center is located at 1, 0, with the radius being square root of 1, which is equal to 1. So here's the center, here's the circle. Now, we want to transform r cosecant theta equals 8 to an equation in rectangular coordinates and graph. Well, generally speaking, dealing with secant and cosecant, we change them to sine and cosine. In this case, cosecant is 1 over sine. So we write r over sine theta equals 8. Cross product will result in r being 8 sine theta. And we use the same trick. We multiply both sides by r again. And it gives us r squared equals 8 r sine theta. The left side is x squared plus y squared. Again, just reminding you, x squared plus y squared is r squared, y equals r sine theta. So the left side is x squared plus y squared, and the right side is 8y. We move it to the left. And we put these two together. And we need to add a number to both sides to make this a perfect square. For this case, b is negative 8. Divided by 2 is negative 4. Squared is positive 16. We're going to add positive 16 to both sides. And we write it in this format. Again, equation of a circle. So x squared plus y minus 4 quantity squared equals 16. That's a circle centered at 0, 4. The radius is square root of 16 or 4. So this is the center, and this is the circle. Identify, graph the equation, and convert to a rectangular equation. Well, r equals 4. If we square both sides, r squared becomes 16, and we know r squared is x squared plus y squared. Therefore, when r is 4, it corresponds to x squared plus y squared equals 16. As you know, this is a circle with center at 0, 0, the origin, or in this case, the pole with the radius, which is square root of 16 or 4. In other words, x squared plus y squared equals r squared. Is the equation of a circle centered at the origin with the radius r. So that's the case. That's the circle. In part B, theta equals 3 pi over 4. Let's see how we approach that. Anytime we have theta, we simply take the tangent of both sides. And as you know, tan of 3 pi over 4 is negative 1. Remember, pi over 4 tangent is 1. 3 pi over 4 is in the second quadrant. That makes it negative 1. And so if you look at this equation and do the cross product, this is negative 1 over 1. Y equals negative x is a line that goes through the origin. So theta equals any angle. Ultimately, it results in a line that goes through the origin, or the pole, if you will. Identify, graph, and convert to rectangular equation. R sine theta equals negative 3. And we know that y is r sine theta. Therefore, y must be negative 3. And as you know, this is a horizontal line. So 3 tick marks down, and a horizontal line is the answer. Or cosine theta equals 4, and we know our cosine theta is x. Therefore, x equals 4, or cosine theta is x. X equals 4 is the answer. We know it to be a vertical line, so to the right 4 tick marks, and that is a vertical line. So in short, r sine theta equals a number is a horizontal line, r cosine theta equals a number. It's a vertical line, and so the synopsis of that is here. R equals A is a circle which is centered at the pole with the radius A. R sine theta equals A is a horizontal line, R cosine theta equals A is a vertical line. When theta is a number, it's a line with the equation y equals tan of theta, whatever that might be, or tan of k times x. R sine theta equals A, that means y equals A, R cosine theta equals A, that means x equals A. And perhaps we should, represent normally this one with B, so we can change that. And when number A is larger than 0, R equals plus minus 2A cosine theta, or R equals plus minus 2A sine theta, all of them are circles. If it involves cosine, then the center is along the y-axis. If it involves sine, along the x-axis accordingly. As far as the symmetry, we have learned it in rectangular coordinate system, the odd symmetry, the even symmetry, and we have something similar to that. So symmetry with respect, WRT with respect to the polar axis. If in the polar equation r comma theta, we can replace it with r comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis. Symmetry with respect to the line theta equals pi over 2. Theta equals pi over 2 in essence is the y-axis, if you will. If in the polar equation r comma theta, it can be replaced by r comma pi minus theta. The graph is symmetric with respect to the line. Theta equals pi over 2, essentially the y-axis. By the way, if both of them work, we have symmetry with respect to polar origin, or if in the polar equation r comma theta, it can be replaced with negative r comma theta or r comma theta plus pi. The graph is symmetric with respect to the pole. In essence, this we call it the odd symmetry if you go back to rectangular coordinate system. And so to graph something from the scratch, such as graphing r equals 1 minus cosine theta, you can always plot pairs, you can add symmetry. So let's just see what's the best course of action. You should always stick with easy numbers. In this case, we are going to go from 0 to pi, but look at the numbers. The numbers we already are using common arcs. By the way, in general, when r is a times 1 plus minus cosine theta or 1 plus minus sine theta, it passes through the pole, and it's a cardioid. It looks like a heart in essence. And so r is 1 minus cosine theta. For example, when I choose 0, cosine of 0 is 1. 1 minus 1 makes it 0. If I go with pi over 6, cosine is square root of 3 over 2. It's 1 minus square root of 3 over 2. If I use pi over 4, square root of 2 over 2, so 1 minus that. If I use pi over 3, 1/2, 1 minus 1/2, which makes it 1/2. If I go with pi over 2, cosine is 0, so it makes it 1. And if I go with 2 pi over 3, makes it negative 1/2. In the second quadrant, cosine is negative 1 minus negative 1/2 makes it 3/2. If I go with pi, cosine of pi is negative 1. 1 minus negative 1 makes it 2. So to give you an idea, and you put them in this format, and you start with theta, for example, just the rough, sketch for a few of those points. If I were to do that, for example, this point obviously would be the pole. If I choose the easy one, at pi over 3 is 1/2, so this is not to scale, but just to give you an idea, assuming this is 2 and the first one is half, somewhere here. And another easy one. At pi over 2 is 1. Let's assume, again, by no means this is to scale. And at pi is 2, the last one is also easy. So let's assume this is 2, so it'll look like this. Again. And I can continue with more. So it looks obviously a lot better here, but you get the picture. You can do it by hand or just the way it is here, which is a lot more precise. If we want to discuss the symmetry, if we replace the theta with negative theta, it gives us the same, and therefore it makes it symmetric with respect, WRT, with respect to the polar axis. So this half looks the same, so it should look the same, right? Because it's symmetric with respect to the line, in essence, the x-axis. For the second half, you can plug in 4 pi over 3, 3 pi over 2, 5 pi over 3, 2 pi, and in the same manner, you can calculate it. Those are all easy numbers. And so, for example, 4 pi over 3 is the same as pi over 3. It's negative. It's positive 1/2 in the third quadrant makes it negative 1/2. So 1 minus negative 1/2 makes it 3/2. So on and so forth. And this is the second half. Let me erase what I have. So if you look at the top half and the bottom half, symmetric with respect to, in essence, the x-axis or the polar axis, it makes it easy to graph. Again, an easy way, simply put, plot pairs. That's all you have to do, a few easy pairs. Plot the complex number 1 plus I in the complex plane and write it in polar form, write theta in degrees. So first and foremost, let's look at these two cases. If you have a point and along the x-axis, we call it the real line, and along the y-axis, we call it the imaginary, and we represent it with x plus iy or yi. And this is exactly the same thing that we have learned, which is a plus bi when we studied complex numbers in algebra. So that's the same concept. So this is the same concept as a plus bi that we have seen, where I by definition is square root of -1. So this is called the complex plane, and z bar or z star, sometimes z hat, it's the complex conjugate. As you recall, the complex conjugate for a plus bi was a minus bi. So for x plus iy becomes x minus iy. As a result, here's what we have. We can represent this with r cosine theta plus I sine theta, and R cis theta is a easy version of or representation of that. C stands for the cosine, I stands for this I, and S stands for sine theta. So this is the abbreviation. It's easier to write it in this fashion. R squared is the good old R squared, X squared plus Y squared. So we are looking at they call, if you take a root of it for the R, it's called the modulus, okay? And that is the square root of X squared plus Y squared. And to find theta, of course, as always, tan theta is Y over X. So similar to what we have seen with polar coordinates. And so in this case, we notice that the real part is 1, and this is plus 1 times I. So X and Y are both 1. And so if we go 1 along the x-axis, the real axis, 1 along the y-axis, the imaginary axis, that point is of interest to us, and we can calculate the R as square root of X squared plus Y squared. And again, as I mentioned, both of them are 1 because the coefficient of I is 1, and that becomes square root of 2. As for tan theta, it's Y over X, and that makes it 1. Therefore, theta becomes 45 degrees of pi over 4. We want to put it in degrees. Therefore, Z, which is 1 plus I, representing in this format, which is a complex format, or square root of 2 cosine of theta, 45 degrees plus I sine of 45 degrees. Or you can even write it in this fashion. Or you can write square root of 2 cis 45 degrees. In short, that's the same thing. Shorthand notation. Same thing. All right. We want to write the complex number 4 times cosine of 7 pi over 4 plus I sine of 7 pi over 4 in rectangular form and plot the complex number. And again, reminding everybody, Z is X plus Y I or R cis theta is the Euler's formula, in essence, e to the power of I theta. R squared is X squared plus Y squared. The modulus of Z or R is square root of X squared plus Y squared. Tan theta is Y over X, just to remind everybody. And this is the complex plane. And so for cosine of 7 pi over 4, as you know, 7 pi over 4, the reference arc is pi over 4. And cosine in the fourth quadrant is positive. So cosine is square root of 2 over 2, sine is square root of 2 over 2, but in the fourth quadrant, cosine is positive and sine is negative. So it's important to remember what is the reference arc. It helps us figure it out. And as you can see, if you multiply 4 cancels out the 2 square root of 2 minus 2 square root of 2i, this is in rectangular form. This angle is theta. 7 pi over 4, fourth quadrant. And you go 4 tick marks in essence. We want to find Z times W and Z over W. In other words, we want to multiply and want to divide complex numbers and leave the answer in polar form. So we're going to keep it in polar form. So I'm going to remind everybody, when Z is R cis theta and all of the above, if we want to multiply two numbers, we multiply the modulus and then we add up the arguments. If you want to divide them, we divide the modulus, the magnitudes, and the difference of the arguments we write. So we want to multiply these two. We multiply these two numbers, and then cosine and sine don't change. We just add pi over 8 and pi over 10 for multiplication. To multiply these two, multiply 2 and 2, add up pi over 8 and pi over 10. The common denominator is 40. Divided by 8, 5. So 5 pi. 4 divided by 10, 4. 4 pi. They add up to 9 pi over 10, over 40, my apologies. We're going to divide them. Z over W. And so we divide the two numbers. They cancel each other. And all we have to do, subtract pi over 10 from pi over 8. Again, 40 is the common denominator, so 5 pi over 40 this time, minus 4 pi over 40. So look at this one, 5 pi over 40 this time, minus 4 pi over 40, which gives us pi over 40. So the point being, if we want to multiply or divide them, if they are in a rectangular form, it's a lot harder than in polar form. What if we want to raise it to a power? So write in standard form a plus bi. In other words, finish the job and then rise it to the sixth power. And so first, again, reminding you about everything we had in the previous page, we are adding the Moir's theorem. When n is larger than or equal to 1, if z is given as RC theta, how do you raise it to the power of n? Simply put, you raise the modulus or the magnitude to that power, and then the argument gets multiplied by n. So let's do that. We're going to raise this to the power of 6, and then we're going to multiply each one by number 6. So first of all, square root of 3 to the power of 6. I hope you realize the same as 3 to the power of 3, because this is 3 to the power of 1/2. In other words, we could write this 3 to the power of 1/2. So to the power of 6 is 3 cubed. And then this 6 goes away, and this becomes 3. And 3 cubed is 27. Now, you can keep the 5 pi over 3 class if you want. You can keep it. But if you recognize that 5 pi over 3, we are discussing the fourth quadrant, in the fourth, and the reference arc is pi over 3. In the fourth quadrant, again, you can keep it like that. In the fourth quadrant, cosine is positive, so cosine of pi over 3. However, sine is negative, so we change this positive to negative if you want to change this to pi over 3. This is one way to do that. And why are we doing that? Because we are supposed to write it in standard form. So cosine of pi over 3, we replace it with 1/2. And sine of pi over 3, we replace it with square root of 3 over 2. So minus square root of 3 over 2i. And everything gets multiplied by 27. And this is the final answer. 27 halves minus 27 square root of 3 halves I. we want to raise this one to the power of 10. Needless to say, it's clear it becomes pretty difficult if you want to multiply 1 plus I by itself 10 times. So we go with De Moivre's theorem, and so we write this in a complex format, polar format. And I hope you remember we did this in question number 9, and you can go back to the same recording. It's square root of 2 cosine of 45 degrees plus I sine of 5 degrees. I want to raise this to the power of 10, which means this gets raised to the power of 10 according to this, and this gets multiplied by 10. So z to the power of 10, we're going to raise this to the power of 10, and we're going to multiply 45 by 10. And this one is the same as 2 to the power of 5, and those 450 degrees. 450 degrees is larger than 360. So if I subtract 360, it gives me the same. So I'm going to subtract 360, and it gives me the same angle, 90 degrees. As you know, cosine of 90 is 0, sine of 90 is 1, and we are done with 32i. So in essence, we raise this to the power of 10 in 30 seconds using De Moivre's theorem. Pretty fast. Z equals 8, find on all complex cube roots. And so we are going to find the roots. We have everything here. We are going to add the concept of roots when n is larger than or equal to 2. If you have r cis theta, and let's say theta we represented with theta sub 0, then the nth root, we take the nth root of r, the modulus or magnitude, and then we add 2k pi, and we divide the whole thing by n. Then we let k be 0, 1, 2, all the way to n minus 1. As you know, any real number is in the form of r cis theta, where theta is 0. I want you to know z equals 8 is 8 cis 0. Z equals 2 is 2 cis 0. So that is the general case. Anytime you have a real part only, no imaginary part, that is your modulus or magnitude, with theta being 0 degrees. You can write it in this format or a shorthand notation. So in this case, 8 cis 0 degrees, or 8 cis 0. All right, so we want the third root. So we take the cube root of this number according to this, or I wrote it here. The third root of the number, whatever this is, and then cis theta over 0, and we know theta sub 0 is 0, the angle that we have to begin with, over n, so 0 over 3 plus 2k pi over n. 0 over 3 just simply goes away, it's 0. So the answer would be z sub k is the third root of 8, which means 2 cis 2k pi over 3, and k can only be 0, 1, 2. So replace the k with 0, becomes 2 cis 0. Replace it with 1, becomes 2 cis 2 pi over 3. Replace it with 2, becomes 2 cis 4 pi over 3. So again, replace the k with those three numbers. Two cis 0. It's simply 2, because cosine of 0 is 1, sine of 0 is 0. 2 is 2 pi over 3. 2 pi over 3 the reference arc is pi over 3. Cosine of pi over 3. So let me just write this as 2 cosine of pi over 3, but it's negative. Let me just keep it as 2 pi over 3 plus I sine of 2 pi over 3. Now, pi over 3 cosine is 1/2, but 2 pi over 3 is negative 1/2, because in the second quadrant times 2, negative 1. Sine of pi over 3 is square root of 3 over 2. In the second quadrant, also 2 pi over 3 gives you the same result because sine is positive, and therefore you have square root of 3 over 2. The 2 cancel out and just gives you square root of 3. So minus 1 plus I square root of 3. 4 pi over 3 has the same reference arc. So what happens is, let's just write it with a different color. So this one is 2 cosine 4 pi over 3 plus I sine 4 pi over 3. Now, as you know, 4 pi over 3 puts us in the third quadrant where both sine and cosine are negative. So pi over 3 for cosine is 1/2, makes it negative 1/2. So this remains as negative 1. Sine is the same as square root of 3 over 2, but in the third quadrant is negative. So minus square root of 3 over 2. With the 2, they cancel each other. So simply minus square root of 3. Therefore, it's minus 1 minus I square root of 3. And this is the last one. And notice 0, 1, 2. So I'm going to call it z sub 0, z sub 1, z sub 2. That's how you find the roots. Complex numbers. Let's move on to vectors. Vector V has an initial point P and terminal point Q. Write B in the form of AI plus BJ. Find its position vector. Also find its magnitude, the magnitude of V, where P is given as 3, 2, Q is given as 5, 6. Well, two vectors are considered the same as long as you move them in such a way that they have the same magnitude and direction, because that's the definition of a vector and the difference between a vector and a scalar. Scalar has a magnitude, vector has both. So if we keep the magnitude and direction intact, they are the same wherever they are. Position vector V, if a V has the components AB, is an algebraic vector whose initial point is at the origin, then V is called a position vector. So it becomes a position vector when the initial point is at the origin. Algebraic vector AI plus BJ, or simply A comma B. E and B are called components of the vector V. A vector with initial and terminal points P having coordinates x sub 1 and y sub 1, Q having coordinates x sub 2 and y sub 2 is equal to the position vector V, or PQ vector. This is the notation for the vector, x sub 2 minus x sub 1, y sub 2 minus y sub 1, and these are notation for the vectors, vector components. So in this case, we are going to write 5 minus 3 and 6 minus 2, which simply put gives us 2, 4. If you want to go with the I and J, we would say 5 minus 3 times I, 6 minus 2 times j, and therefore we can represent it with 2i and 4j. And the magnitude, let's remind everybody, the magnitude is the square root of a squared plus b squared, and there are some properties. The magnitude is greater than or equal to 0. If it's 0, v must be 0, and the magnitude of two vectors is the same if they're opposite of each other, and if you multiply it by a, it gets stretched by that much with the absolute value of it. So square root of a squared plus b squared means 2 squared plus 4 squared. This is 4. This is 16. They add up to 20. So this is the square root of 20. And as you know, twenty is 4 times 5. Therefore, 4 comes out as 2. 5 remains. And the magnitude is 2 square root of 5. 2 square root of 5. Given v is negative 2i plus 3j and w is 5i minus 4j, and we want to find the magnitude of v. Let's do that first using this formula, which means square root of minus 2 quantity squared plus 3 squared. And as you know, this is 4. This is 9, and that's square root of 30. So that's the first part. The second part is asking for v plus w. So simply put, add up these two component-wise. By the way, this shows how you add up. This is a picture that shows you how you add up with u and v. And then if you want to add it up to w. And when you add up, you can use a triangular method or a parallelogram. So now we're going to add the components. Negative 2i and 5i is 3i, 3j and minus 4j is minus j. So that's how you add them up component-wise. Finally, 2v minus 3 times w, that means 2 times this minus 3 times that. To do the math, we are going to distribute. So this is minus 4i plus 6j minus 15i plus 12j. And obviously, these two add up to negative 19i. These two add up to positive 18j. So adding, subtracting, finding the magnitude, things of that nature shouldn't be too hard. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. So reminding everyone, v or pq is x up 2 minus x up 1. This is the vector components, x up 2 minus x up 1 or comma y sub 2 minus y sub 1. That's a position vector. Magnitude is simply square root of a squared plus b squared. So we want the magnitude. Let's add up a squared, 3 squared, and 3 squared. As you can see, this is 9, this is 9. So this is square root of 18. And the reason square root of 18 is 3 square root of 2 because 18 is 9 times 2. We want to find the direction angle. So let's remind everybody that a vector v is the product of its magnitude and cosine alpha I, the I direction, plus sine alpha j, the j direction. And alpha is the direction which is normally positive, okay, from 0 to 60. And it's the angle that v makes with the x-axis, in this case alpha. So how do we find that? When V is given as 3i plus 3j, tan of alpha is y over x, the component for j over the component for I, which is 3 over 3, makes it 1. And since it's in the first quadrant, the answer is simply 45 degrees or pi over 4. This is in the first quadrant, 3, 3, somewhere here, right? Therefore, we're going to write the magnitude of V times cosine alpha I plus sine alpha j. Representation would be 3 square root of 2 cosine of 45 degrees I plus sine of 540 degrees j. So this is the vector, and the next thing is the unit vector. So unit vector in the direction of V would be just dividing the vector by its magnitude. So let's divide the vector by its magnitude. Here's the vector, here's the magnitude. So if we divide it by that, it becomes a unit vector. So V has components A comma B. So A times 1 comma 0 plus B times 0 comma 1. This is the I vector, this is the J vector. This is just, it's, the sign needs to be fixed. So divide by 3 square root of 2. And as you can see, each one, the 3 cancels out. Now, 1 over square root of 2, I hope you know it's square root of 2 over 2, or you can do the math. Let me just quickly show you 1 over square root of 2. If you multiply by square root of 2 over square root of 2, you get square root of 2 over 2. That's why you get to this answer. Needless to say, you can always check by raising this to the second power, raising this to the second power. They must add up to 1, and then their square root must be 1, and that proves that it's a unit vector. We want to write the vector V in the form of AI plus BJ, given its magnitude and the angle alpha it makes with the positive x-axis. Also find the unit vector and check. We're going to also check it. We didn't check it last time. Let's check it here. Where the magnitude is given as 14, A is given as 120 degrees. And this is, again, reminding everybody about the synopsis of this concept. So a vector V has the magnitude. So we're going to put 14 times cosine alpha, cosine of 120 I, plus sine alpha, sine of 120 J. That's what we are going to do. So we're going to plug in the numbers. Now, this is theta, and the reference arc is 60 degrees. Cosine of 60 degrees is 1/2. This is in the second quadrant. Cosine is negative, so negative 1/2. Sine of 60 degrees is square root of 3/2. In the second quadrant, sine is also positive. So that's what we get. So I want everybody to know y negative, y positive. 14 cancels out the 2. So this becomes -7. This becomes 7 square root of 3. So we wrote it in this format. So the first part is done. The next one is to find the unit vector. All we have to do, divide by its magnitude. So let's divide by 14. And when we divide, this becomes 1/2, this becomes square root of 3/2. So negative 1/2 I, positive square root of 3/2 j. I'm assuming everybody can do this elementary algebra dealing with fractions. And so to check, we're going to square this number, we're going to square this number, and we're going to add them up. In essence, we're looking at what's underneath here. This becomes positive 1/4. This becomes positive 3/4. The answer is 1. And obviously, square root of 1 is 1. This is how you check. And not only we came up with the unit vector, we also checked. So that is really a good practice. Finally, let's look at an application. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree or just degree. We're going to stick with degree because it's given. So we have north 55 degrees east. We are going this way with the wind blowing from west to east, resulting in the true direction here, which we're going to call it P sub G. So this angle, if we come up with, then the answer to the question, we can come up with this, which is 90 minus theta. So what is the ground speed? It's the magnitude of this vector. What is the direction? North. 90 minus theta, because this is theta, east. So what do we need to find? We need to find theta. So 90 minus theta goes here. We also need to find the magnitude of this, which is adding the magnitude of, adding the two vectors here. Not the magnitude, adding these two vectors and finding the magnitude. So here's what we have. The velocity relative to air is given as 200 miles per hour. And theta of alpha is 90 minus 55 degrees. If we are going in this direction, north 55 degrees east, the angle we want is with respect to the positive direction of x. So this angle is 35 degrees. In other words, this angle. The wind has the magnitude of 35 miles per hour, and it makes a 0-degree angle because it's going from west to east. It's parallel to the x-axis. The angle for that is 0 degrees. So let's go with the component. Let's write this for each one. For the first one, 200 cosine of 35 degrees I plus sine of 35 degrees J. We need to use a calculator to find the cosine of 35 and sine of 35. This is what we get. We do the same thing for the wind, and the degrees 0 degrees. Cosine, as you know, is 1. Sine is u. Therefore, it's only 35I. Now, velocity relative to the ground, we are going to add the two vectors, VA, V sub A, and V sub W. And when we do that, that means we add these two numbers, 198.83I, and this one, there is nothing to add to it, we just write it. And now we are practically there. So we want this magnitude. That means we are going to use square root of a squared plus b squared. That means square this number and square this number, add them up, take a root, and use a calculator. It's about 230 miles per hour. And tangent theta is the ratio of this to this, 114.72 over 198.83. So that would be tan of theta, which gives us about 30 degrees. So now we are ready to move on. We have this number, 230 miles per hour, and 90 minus that, we have that number, 60 degrees. So it's north, 60 degrees east.